Hi, my Tech Decipher. This is video 3 in the series CSEC Physics Formula Book. Wonder what I'll do when I don't know. If you watched the last video, you know that we're doing weight in this one. So let's go. So let's start off as usual with a definition of weight. The weight of a body is the force of gravity on the body. An object on Earth will have a different weight if it is on another planet with a different value of gravity. So on Earth, the value of gravity is 10 newtons per kilogram, but on Jupiter, the gravity is 25 newtons per kilogram. So the same object would have a different weight on Earth versus Jupiter. However, the mass of a body is constant no matter where it is located. So that simply means, though the weight would be different on Earth versus Jupiter, the mass will be constant no matter where in the universe the body or the object is located. So the mass of a body is actually a measure of the quantity of matter that makes up the body. And that is why it is constant no matter where in the universe the body or the object is located. So now let's further explore. Symbol for weight, it's a capital W. The formula for weight, weight is equal to mass times gravitational field strength. In symbols, it is W is equal to mg. Remember, capital W. Next, we look at the SI unit of weight. And the SI unit is a capital N known as Newton. Now, let me just interject here to say that as a general rule, the names of units are written with common letters, even if those names represent scientists' names, like the Newton. So a constant that we can look at for weight is gravity. So this is one of those constants that we would need to remember. For Earth, the gravity is 10 newtons per kilograms, and sometimes you'll see 10 meters per second squared. Either unit is acceptable and can be used. So let's now jump over into the application of weight. Question 1 reads, a body has a mass of 55 kilograms. What is its weight on Earth with gravity 10 newtons per kilogram? Let's now go through and do the calculation. So of course, the first thing we should do is to record what we got. All right, so now we will just write our formula. Weight is equal to mg. And you know from algebra in math, once you are multiplying and you're working with letters, you don't need to put a multiplication sign between them. Just writing them side by side already implies multiplication. So we don't need to do that. And that's the weight of this body on Earth. Let's now go over to question 2. The force of gravity on a planet is 1.6 newtons per kilogram. Calculate the weight on Earth if the weight on this planet is 6.4 newtons. So just a tip, when we're working with gravity on different planets, it is advised to use subscripts to distinguish between the two. So just as a interjection, a subscript, if I had X here, the subscript is written a little lower than this normal text. It just indicates that there are different values of a particular quantity. So you have the N there being a subscript. And we know, of course, when letters or numbers are placed a little higher, then these are superscripts, which we know are the same as exponents or powers. So now let's highlight what we got. So now what I'll be doing is to calculate the mass of the body, since we have the weight on the planet as well as the gravity of that planet. So now they ask us to find the weight on Earth. And there you have the answer to the question. So for question 2, we had to do a little bit of extra work in that we had to first find the mass of the body. We were given the gravity on another planet as well as the weight on that planet. Then after finding the mass, we then substituted it in the formula to find the weight on Earth. Hope you were able to understand what we did in this video. And of course, it's your turn. Try to see how best you can complete these questions before looking at the answer sheet. After you're done, go in the description, download the answer sheet, and check to see how well you did. There you have it, another in the series completed. Let me know in the chat how these videos have been helping you. And of course, remember, give the video a like, share, and of course, subscribe. Catch me in the next one where we're looking at moments. See you then.